Hey guys, welcome back to the shop. Let's go ahead and get our hardtail nut finished up here. We've got one more machine feature that we need to do for this thing to finish it so we can move on to the final assembly and get that vise put all back together. So what I want to do is pin this guy. In the previous video, in case you missed it, we modified the original hardtail nut here. We went ahead and took, these were the original threads that were on here, put in a lathe and parted that off. We machined a new Acme nut for this. And then we threaded these two pieces together with a male-female thread fit, and we used our 680 Loctite whenever we screwed that together. And I feel very confident that that Loctite will hold this thing for what it's doing there. But let's just go ahead and reassure that it will never break loose. Honestly, with the Loctite, you have to heat this up with a torch to get that Loctite to break loose in order to get them to unscrew. But we want to go ahead and secure it with a pin just to be sure that it never does unscrew inside there. So I wanted to do a tapered pin on this guy, but I'm just worried that it's going to be, it's so close. We've got to split this wall right here, and it's so close to this outside diameter that I'm not really sure a tapered pin's the right fit right there. So I decided we're going to use a spring tension pin. I got a little assortment of these guys, and I went ahead and landed on the 1/8 diameter pin. So I know it's a small pin, but it's going to work just as good as if it was a 3/16 or whatever, even a 1/4 inch. So we'll get this set up in the mill, find the offset where we need to be to split that wall thickness, and we'll drill a 1/8 hole down through there and then drive the spring tension pin in there. We'll cut it off, and we may even, well, maybe just file the top and bottom, but we'd like to kind of shape the pin so that it matches the outside radius of the nut there. But that's the plan. So we'll start with a 1/8 diameter 2-flute end mill, high-speed steel end mill, so that we can get our flat established, and then go in there with our drill. We'll center it, use a center drill, and then drill it all the way through there, and then drive the pin in. So that's a plan of attack. Pretty simple operation there. We'll go to the KBC milling machine and get this set up and go ahead and get it drilled for our pin. I've already got our vise trammed in here, so it's nice and straight, just ready to go. We'll set this in here, and I want to let this hang out just so we got plenty of working room right here. That should be adequate right there where it's at. And then as far as the alignment, those two drilled holes on that end, I'm just going to visually just rotate them so that it looks like they're up and down, and that looks good right there where it's at. Get our vise tight, and we'll go ahead and bump this guy down. Okay, that looks good. Now I'd like to set up a machinist jack out here to just support the weight of, you know, our tool pressure going down on that. So we'll go ahead, I've got this, we've got our Edge Tech machinist vise right here that we can set up under there. The way these are machined, which is the way jacks should be machined, is that they match the bottom height of all of your standard 6-inch milling vices there, with a little bit of room to work. And then that'll cover that T-slot there. We'll get our T-nut and bolts in here. That should work just fine right there where it's at. All right, and just run the screw up. And it is going past the center line of the nut there. Just run it up by finger tight like that. The pad here has a nice knurled surface, so you can easily grab it with your fingers and put some pressure on it. But there's holes there, so you can use a pin to apply some pressure too. So that should work good. Keep it from pushing down as we're drilling. So we'll get an edge finder in here and go ahead and locate our drill position. All right, we're going to use a 1/2-inch edge finder. We'll start with the face and move down. I want that to be 2.5 inches from the end of the nut there. The nut that we machined is 3 inches long with a 1-inch shoulder length machine on that. So to be the center of our thread will be 2.5 from this face. All right, that's kicked off there. X0. So that's going to be a 2 3/4 movement there. You got to add a 1/4 inch for the edge finder. That should be our X. Now we can find it this way right here. Now before we do that, let me point out, so what we're doing is once we find the diameter, outside diameter, we're going to move the center line of the spindle in 3/16 of an inch. So this is a 2-inch OD. The OD of our threads we machined is 1 5/8, so that's a difference of 3/8 of an inch. Divide it by 2 is 3/16 per side to get to that 1 5/8 diameter. So if we move it in 3/16, we should be right down the middle of those threads back there. All right, Y0, so that's going to be an offset of 7/16, because again, you got to add the 1/4 inch for the half diameter of the edge finder. And that should be good right there. That should be where we're going to be drilling. All right, I think what I'd like to do is we'll just put a drill in there and we'll come back down this face and just visually verify that it is in the right spot. All right, that looks good. That should be right. Should be right on the 1 5/8 diameter. Okay, all right, so we're gonna start with an end mill and get our flat established. Then we'll go back in with our drill and get the hole drilled. 1/8 diameter, 2 flute high-speed steel end mill. This was one of Dad's end mills. Some of the new old stock that I've got from the old shop. We're going to use that, come down here and get us a nice round hole milled in there. We'll set you up for a nice tight shot so you can see that. We're going to start with a split point 1/8 diameter drill bit there. That's to help establish the center of the hole and get the hole started that way. And then we'll swap that out and put a standard jobber drill in there, 1/8 diameter. Should be plenty good there. We'll go ahead and swap that drill out now. All right, well that drilling went nice and smooth, no problems there. So we got our 1/8 diameter hole. What I'll do is I'll measure what that is and go ahead and trim a little bit of this pin off. And I think we'll go ahead and just drive it in right here where it's at, since it's clamped up and we got some support. And once we drive it in, you could easily take a file and just kind of file and dress this down and kind of blend that together. There's nothing wrong with that technique there. But for me personally, I'm going to set this back in the lathe in our steady rest and use the tool and probably go ahead and shape this pin to match that radius there. Just going to use our calipers to get a general dimension of what that length would be. I'm going to say 1 3/8 is going to be plenty. All right. Go right back into our lathe so we can turn this pin. All right, so that should work nice. We'll just use a, probably just use a high-speed tool bit, come in here and turn that and see if we can match it up nice and close. Apparently the high-speed steel is not the best choice for that, so we're going to just go ahead and take that out and go with some carbide, because it seems to be wearing the tip of that tool out. Okay, well I believe that finishes up the lathe work. That worked out pretty good. We got it turned down. I left it just maybe a couple thou over that surface. I was trying not to cut a ring in that OD, and we just used our 220 emery paper to kind of blend it down and knock the rest of those high spots down. But now when you rub your finger over that, it just feels like a nice smooth transition all the way around where the pin comes out. So this guy's ready to go. We're going to take this out. I'm going to get everything ready, and we'll go ahead and start the assembly of the hardtail vise now. All right, let's get this spindle in the vise. Let's get it back together. So I was going to show you, here's our counterbore here and our thrust bearing. Got the thrust bearing, the washers, and it's going to sit right in this counterbore just like so. And then the flange of the meatball of the spindle is going to be, pushed against that washer and spin just like so. So we'll have to slide this down the spindle to that shoulder there. And then as we feed the thread through there, we'll have to slide our other thrust bearing on. It's going on the back side, the spring, and then the lock collar here, the split collar that's going to tighten it all, keep it in place, I mean. All right, so let's get rolling. Put a little bit, I'm just using my whey oil to lubricate the ball bearings and the screw. I'm going to go ahead and put some more of our whey lube right here on the threads. Close fit. All right, this is our thrust bearing. And I think we're ready to go through here with it. All right, we're going to take our other thrust bearing. Let me shoot a little bit of oil on this again. Washer, bearing, and then the next washer right here. And then we have our spring. That was the culprit of the last install. All right, and then we've got our split lock collar going on there as well. And just got to work it in there. There's really not a lot of room. Everything's getting hung up on those threads there. All right, what's the secret formula to get all this to slide in the thread there? It's getting hung up. Come on, man. Is it the collar that's messing with me? There we go.
Okay, come on. Keep it going.
I remember this being the, it's not hard, it's just, it's a little bit annoying trying to get all this together through here and get all these to continue sliding forward. There we go. There we go. Okay. And there it is. All right. So I'll have to find, I believe I used some kind of pry bar last time that we can put a little pressure on the spring just to keep everything captured nice and tight as we tighten down that collar. All right, we got a little pry bar and another wrench here. Let's see if we can make any more progress on this. I'm trying to just get the collar, get it compressed a little bit. I'm trying to push in on it, get the slack out. Let's see if we can get it to stay right there. Of course not. It's not going to stay. I can't keep it all from moving on me. I want it to compress. It's been a battle till the end, but I finally got that collar tightened up where it needs to be with enough compression. If you don't get it tight enough, the meatball will actually, you can kind of pull it on the spring tension a little bit. So now I've got it. I'll show you my setup here. We put an angle plate and a wooden block here. Now it's nice and tight. Now when I pull it, I'm not pulling that spring tension. But what I did was just put an angle plate there and a block. And I just tried to build up something just to keep it all centered. So we got an angle plate, V-block in there to hold the screw kind of in line. And then of course all these clamps to hold everything down, just keeping it together there. So the trick to this is what you see, this is kind of a hodgepodge setup. But if you can get it held together, and ultimately what I'm seeing, you got to keep the spindle from going that way. You got to keep the dynamic jaw from moving around. And what we need is a piece of tubing that will slide over the spindle all the way to that collar that comes out here. And if you could have a way to compress it, you know, like another screw or something to just push it that way and hold it together so you can tighten up that collar. I'd imagine whenever they build these vices right here, they probably got some kind of special tool to set up to make that job a lot easier. One-time deal, I just kind of had to throw some stuff together, and this is it. This is what you see. But we finally got it, so now we're ready to go ahead and put it in the body. We're going to go ahead and oil this surface down really well, put a little bit of oil in that too, and then we'll slide this together. All right, our hardtail nut is ready to assemble. So there's our hardtail housing right there, which is, this is where it's going to fit like so. It's going to slide all the way up in there like that, get bolted in. I've got all of our bolts there ready to go. We're just ready for the assembly. And of course we got our dynamic jaw there assembled, ready to go. Got our new spindle in there, the new handle. Still very, very happy with the way that spindle turned out. Just looks so pretty. So we'll move over to the other side and start getting this guy all put back together. We'll use our hardtail vise to hold our hardtail vise pieces for assembly. I'm just going to put the hardtail right up here because these are the jaws that have the parallels machine in there, the steps, so you can set something flat in there. So we'll set this guy up in there to hold it. Just like that. And that's easier because now we have a space under here because the hardtail nut will actually stick out past this a little bit. Easy as that. Now it's time to go ahead and get it on the main vise body. Just getting rid of any dust that's settled on that. We've been keeping our SP350 on there, which is doing a fine job. We haven't had any flash rusting on that casting since we started working on it because of that. We'll grab the hardtail and go ahead and get it bolted on there. Go ahead and get our bolts ready right here. All right, here's another good look at the way the hardtail nut works. You can see that whenever the spindle is screwed into the nut here, as it's tightening everything up, all of the force is being applied on the center of the hardtail housing, which is transferred to this surface right there. All right. We can get these top bolts in there. The bottom ones should be easy enough. There's one started. All right, we got the two up top, and then there's two on the bottom side there as well. All right, here we have it. I'm going to go ahead and tighten down our clamping bolts here, our flange bolts, keep it from rotating. All right, last step is to get it in here, get that screw lined up and get it screwed in. One thing I was going to do before I forget, I wanted to put a little bit of whey oil in there on those threads. This Eagle oiler's got some whey oil. Just like that. That should be plenty. I'm going to go ahead and put a little bit on this chin right here too. All right, let's get the jaw in there. I'm just going to use brute force for this right here. It's not too bad if you hold it underneath your arm. Just cradle it like that. Set it on there. And there it is. Tricky part is getting the spindle to line up. And we got her going. That has been something that I have thought about for a long time now, and it's very exciting to see it finally come together, just like we were hoping to. It's got a really close fit on it, honestly. Really close fit. It really does have a really nice fit. In fact, it's actually a little bit tighter than what you would want a production vise being, just how close I've got that thing fitted together. I mean, you can see the handle's not even falling down. And part of the problem, it's not necessarily a problem, but I think the issue that I have is that the absolute dead center of the dynamic jaw is not perfectly aligned with the absolute center line of where the hardtail nut is sitting in there. Because when we machined these castings, we had no reference surface to go off of other than the previous surface that we machined. So I tried to center up inside this housing here in the shaper to try to get it as centered as I can. And the same thing with the hardtail casting back here. A while back, whenever we had this set up in the tool room mill and we machined that counterbore in there, you know, we tried to find the center of it the best we can. So I just think that this dynamic jaw here and the center of the nut that we just put in there are not absolutely perfectly in line, straight in line. That's not causing the vise not to work. You can see that it's working just fine. I just think that's why we have a little bit of tightness in there more than what it probably should be, but I think it's beautiful fit. And you know, we've got our thrust washers, our thrust bearings, we got our spring tension in there. So look at the backlash here. I mean, there's literally none. As soon as you move the screw, watch this gap here. Just, there's no backlash. And that is, let's see, that's because I've got these flange bolts loose. Still not tight. Come on. There we go. Beautiful though. I am super happy with it. And I'm happy to see the project winding down near the completion stage. We only have a couple more things to do and this vise is going to be done. All right guys, well that's going to wrap up today's video and the majority of the project for the USA made hardtail vise. I've had a lot of fun with this project, everywhere from, you know, taking all of the raw castings and machining them so that they all fit together. We have all of our custom parts that we have designed and machined, our flange bolts with the washer, the center pivot bolt that we machined. The spindle was a heck of a project, turning the ball end on here and then making our precision fit on our vise handle here, and of course the ball ends. Everything's come together really good on this, very well. And I am just, I'm more than happy with the outcome of this. I think it's been an excellent project for the channel, for the shop. I've enjoyed sharing all of the different machining steps, you know, with the audience out there on the social pages. And I just don't know what else to say about it. I mean, this is a truly awesome vise, and it's definitely a one of a kind, unique, being that I've machined all of it. I've machined the parts for it, you know, the customization for it, and put it all together. So highly unlikely you're going to find another hardtail vise exactly like this one right here, unless some other guys out there decide to make their own parts for it too. But if you followed the playlist and the series on this, you can see we've got a lot of videos on this. And one of the things that it really does show is just what all is involved with manufacturing something. This vise is an idea that Jason at Fireball Tools, he had for a very long time. And I remember standing in Andrew Alexander's shop with Jason. It was just us three, and we were walking through Andrew's shop over in Dallas, looking at his vise collection. And I remember Jason saying to us, he said, I want to make my own vise. And it was cool because, you know, Andrew has pretty much every kind of vise that's ever been made in his shop. You know, he's got a heck of a collection. And so we were pulling out lots of different brands and different manufacturers of vices. And I could see the wheels turning at that point with Jason. He was looking at all of these different vices, and he was kind of picking them apart about what design on each vise he really liked and what he would like to implement in his own design. And he's done a heck of a job trying to find all of the weak points or the failure points or whatever needs improvement to make a stronger, better vise that is going to last someone a lifetime. And quite honestly, it should last many lifetimes. These are high quality tools that will last you your whole career, and hopefully it can be passed on to somebody else, you know, that comes up through the trades. This vise right here is just a really fun project that we've had for the shop, and it's just going to be a centerpiece for the shop. I really don't plan on using this. I mean, we may use it. I'm not going to say we won't, but I have the other one right here, the red one, that we're going to be using. That's the working vise. This is more of the conversation piece that we can use to just kind of represent some of the parts that we've done here for the channel, you know. But I got to thank Jason again for the opportunity for collaborating with him on this. Jason was the one that offered to send me all of these cast pieces and said, hey, I'll send you the castings if you want to machine it yourself and maybe put it on the channel. And I thought it was a great idea. And I told him, yeah, man, send them on. I would love that. And that's what he did when he sent me the hardtail vise there. All of this stuff came, and we wanted to just make a channel project out of it. And I've had a lot of fun doing that. So the only thing left that I really want to machine on it, honestly, is I want to make my own jaws for it. So that's going to be something that I'm going to be working on. We're just going to wait a little bit on that because this isn't really needed right now. But I do want to machine my own jaws for it. And I haven't decided how I want to make those jaws. They may not be aluminum, they might be steel. But I think I would like to make a set of jaws for it that has the step machined in it and has the V-grooves machined in it too for holding rounds. So that's kind of the idea that I have for some custom jaws. Maybe even mill the serrations in there too to give it a little bit of bite, you know, for the vertical flat surfaces in there. But other than that, that's really all that's left as far as the machining. The last major step for the vise is obviously putting some paint on this thing, some color. That too, I quite haven't figured that out yet. I don't know what I want to do because I want to make it right. You obviously have the option to have powder coating done. I'm just a little bit nervous about letting somebody powder coat it because I'm afraid that they're not going to protect the machine surfaces on it that I want to have protected. Not that they can't do it, I'm just kind of worried that somebody's not going to give me what it is that I'm looking for. So we may just make this another channel project and do this ourselves right here. Just maybe whenever the weather's a little bit cooler and we have the door open, we can see about getting us a paint gun and having us some custom paint made up, and maybe we just paint it ourselves and highlight these features in here, you know. And the other idea that I'd really like to have is have something painted on the back here, the hardtail. I would still like to entertain the idea of finding or connecting with someone local in Pensacola that does, you know, painting or artistic work, somebody that really knows a paintbrush, and maybe have somebody come in and do some kind of hand painting on the hardtail. That's how I envision maybe doing this section back here, you know, having something on both sides of the hardtail. And that can come after we paint it here and get the color on it. I haven't even decided a color for it yet too. I love the red. I love the factory hardtail red on there, but I don't know, do we make it red or do we make it a different color? I'm really not sure. The other colors that I've kind of leaned towards is, you know, my thought process is one being a black color, maybe a really dark gray color, and the other one is some kind of green color. You know, green is really, I really kind of have fallen into liking greens, different shades of greens over the years. I guess I get it after my dad, but I'm really more into like the olive greens, the darker shades of greens. But again, I don't know what color it's going to be. I'm just kind of thinking out loud. So I'm planning on making that another project to follow up on whenever we get to the little bit cooler months, when it's not so hot outside and I can open up the door and we can do a little bit of painting right here in the shop. Unless I'd come up with a powder coating option that's going to make my life a little bit easier, but maybe we just keep it all in the shop and just do it ourselves right here. So anyway, we're gonna go ahead and sign off and wrap up this video. I hope you enjoyed watching today's video, and I hope that you've enjoyed the whole project. If you haven't seen all the videos, there's a playlist on YouTube that's got every single video from uncrating this stuff to right now, getting it all completed, okay? And I'll be sure to bring you guys back whenever we start working on it again, when we design some custom jaws for it, and when we start putting some color on this thing, all right? So I hope to see you here on the next project, and we'll see you then.